Oh dear, I seem to have frozen in an embarrassing position. So, welcome viewers once again. We have a very interesting show tonight, but I want to bring you up to speed with what happened, what went wrong, as it were, last week when Blair Whitby was unavoidably detained. And we had those of you who watched will know that we had a chat with him after the alternative program that we agreed to show. And you may like to know that we have now, Blair and I have now agreed a date, and he's coming back to us on the 1st of July. So look forward to that. Meanwhile, tonight we have evolutionary psychology. I know this is a very interesting subject, particularly to me. I hope it is to you. And my guest is Dr. Ed Morrison, and here he is.
Hello.
Ed. How the devil are you? I said, how the devil are you?
Oh, I'm very well, thank you. Thank you. Very well.
Good. Excellent. Well, first of all, I think the first thing to clear up is, what is evolutionary psychology?
So evolutionary psychology is an approach to understanding behavior. So imagine you were a naturalist in the 19th century, or maybe you're in the future, you travel to some new planet and you discover a new form of life and you observe it, this creature, whatever it is, behaving in some way. You could try and understand its behavior from different perspectives, but one perspective you may well take is an evolutionary perspective. So how has evolution shaped this animal's behavior, the way it finds food, the way it finds shelter, the way it reproduces, and so on. And by understanding evolution, you can understand its behavior. So evolutionary psychology is exactly that, applied to any species actually, but in particular, if you're a psychologist, you might be interested in humans, so you can try and understand human behavior in that way.
I speak to a lot of people who don't think that behavior can be inherited. And I always tell them, because they think physical characteristics can be inherited. You can pass on your blue eyes or your running muscles or whatever, but they don't think that behavior per se can be inherited. What would you say to them?
Well, there's a sense in which there's some reasonableness to that, because behavior can be quite different from other physical traits, but not that different. So learning is extremely important for many behaviors, including our own species. So yes, you should all consider how behavior is modified by experience, in other words, learning. But it is also certainly inherited. So, I mean, an example that Darwin used when he was giving the evidence for evolution was consider the domesticated animals, consider those that have been changed through selective breeding. So he was really interested in pigeons. He got all the world's top pigeon fanciers to give them accounts of pigeons, and think about dogs and, compare them to wolves, think about horses and farm animals and so on. Their behavior is quite different from that of their wild ancestors. So dog behavior can be similar to wolves, but it's also pretty different. I wouldn't want a wolf as a pet, but a dog as a pet is just fine. And those differences are not just down to learning. They're down to the way that the animals have been selected for, in this case, by humans. And evolution can select for behavior in exactly the same way. I mean, there's a very simple example. I mean, behavior is just, activity of an organism. So something like your heart beating or your lungs breathing, that is behavior, okay? I think everyone would agree that that's inherited. For a start, if you have to learn how to do that, then you're going to die before you ever get a chance to learn it. So I think everyone can see at that very simple fundamental level, behavior is inherited. And once you've accepted that principle, then it's no harder for evolution to select other kind of behaviors as well. And I'll try and demonstrate some examples of that when I do a presentation.
Okay. Well, I always say to these people that if they don't believe that behavior can be inherited, they should go and try and herd sheep with a wolfhound.
Yeah, exactly. Yeah.
They'd soon learn the errors of their ways. But there is an overlap, isn't there? Because, for example, a cousin of mine, he wasn't raised, he had a stepfather, but much later in life, he discovered who his biological father was. And he, at that time, the man had died, but he went to visit the family, his stepsisters, half sisters, his half brothers, and they said, "You walk just like our dad."
Yeah.
And I'm thinking, well, that may be inheritance of behavior, but it may also be inheritance of skeletal and muscularity. There's a merging there, isn't there?
Yeah, there can be. I mean, there's a whole related field of psychology called behavior genetics, which is looking at exactly that, how important are genes in differences in the way people behave. And we can talk about that, a fascinating field in itself, but the very simple answer is that in almost any behavior you want to look at, genes are very important.
Yes, indeed. Well, I can see that we have a viewer from Spain, and I'm expecting some others from South Africa and Canada tonight. However, you've got a presentation that you've prepared for us, I believe.
Yep.
Would you like to cue that up?
Yep. Okay. Is that on screen now?
It's about to be. There we go. Now, what I'm going to do is I'm going to disappear.
Okay.
And full screen your video, your PowerPoint.
Okay.
Unless you want to remain on screen yourself, but alternatively, you could do voiceover from behind the scenes.
I don't mind. I can't see myself, so I don't mind if my face is on. I'm happy to leave it up to your preference.
Okay. I'll say goodbye for the moment.
Okay. Shall I go ahead and start? Okay, so I'll try in about 10-15 minutes, something like that, to give an introduction to evolutionary psychology. And as I mentioned at the start, the essential idea here is to try and understand behavior in the way that any psychologist would, or that any zoologist would if they were studying animal behavior. And there's really one question that you want to ask to try and understand psychology, behavior, and it's why. Why is an animal doing this? Why is a person doing that? Whatever it might be. But there's one, that simple question hides one complexity, which is that the word why can actually mean several different things. So my starting point is not with a human psychologist, but with a very famous zoologist, this chap here, Nico Tinbergen. And he's very famous in the field of zoology for studying natural animal behavior. And he made this point that the word why can mean these four different things. So we'll call them the proximate, the ontogenetic, the phylogenetic, and the functional why. So the proximate why is to do with mechanisms of behavior. So what is the trigger of the behavior? What is the hormone responsible for it? What action of the nervous system is involved? What environmental inputs causes the behavior, and so on. Okay. But there's another sense of why, which is how does this behavior develop over the course of the animal's lifetime? So is it a kind of instinctive behavior that's just present, inherited, and is not modified? Is it something that can be modified through experience? Is it something that's entirely learned? So this second why is all about the developmental changes in that behavior. So these two whys are quite common. I think people pretty much get exactly what they mean. But he then pointed out there are two further whys, deeper, sort of more hidden whys, which aren't always so obvious, and certainly not to psychologists. So the third one is the phylogenetic why, or the when in evolutionary history. So here we're talking about when has this behavior evolved in the distant past? Is it something that is shared by other members of the species or members of other species? And how deep does that go? Is it something that's unique to one particular species? And then the final why is the functional why, sometimes called the ultimate why. And this is in terms of evolutionary fitness. So in the same way that Darwin showed that if any trait improves an animal's fitness or any organism's fitness, then it will spread throughout the population. So too, any behavior might increase or indeed decrease an animal's fitness. And if it increases it, you'd expect it to spread as well. So you can ask the question, does this behavior increase fitness? So evolutionary psychology is this fourth functional why, Whenever you're asking this question, you're doing evolutionary psychology. And the phylogenetic why, that's the realm of comparative psychology, which means comparing different species and looking for their similarities and differences in behavior. And that's a very closely allied field. And I'll try and give you some examples to show you that it's really useful to think of these two things in conjunction. Now, this way of thinking is pretty standard in biology. It's how most biologists understand behavior, but it's not standard in psychology. So the vast majority of psychologists are comfortable with the first two whys, the proximate and the ontogenetic or developmental, but it's not so natural to think in terms of phylogeny or in terms of evolutionary fitness. So we'll do a quick thought exercise. I'm going to give you a behavior, and we can think of some different explanations for that behavior. So here I am, I live in Portsmouth, and one day walking down Portsmouth High Street, I see two men standing chest to chest, beginning to get aggressive with each other. And I ask myself, why are they doing this? Okay, so you can think of lots of explanations that could all be correct. So for example, maybe one of them was chatting up the other one's girlfriend, and the first one got angry and was going to start a fight about it. Okay, or maybe maybe one of them tried to steal something. Maybe, one is sitting in their seat in the bar, whatever it might be. That would be approximate explanation for that behavior. You might also say something like, well, maybe these two men have lots of testosterone. Testosterone is a hormone associated with aggression, and maybe that is causing them to very swiftly become aggressive with each other. You might take an alternative view and say maybe these guys were raised in houses where violence was used to solve arguments, and so they're just exhibiting that learned behavior. Those would be developmental explanations. But then a phylogenetic explanation would be something like this. These are primates, and these are male primates exhibiting typical male dominance behavior. So in many primate groups, the males, or indeed the females, will compete to establish a social position in the hierarchy, and they can do that with aggression, and that's what these men are doing here. And then finally, the functional why could be something like, well, these men are doing this because one wants to make sure his girlfriend doesn't run off with someone else, wants to stay with him, or he's making sure that other people respect him in the group and realize he's not a pushover. And ultimately, that could translate into some kind of fitness. He's higher status, he keeps his partner, and so on. Okay, so that'll be a functional explanation. So you can do this with any kind of behavior. So here's another quick example I'll go through very quickly. We might ask the question, why does a mother feed her baby when it cries? Now, if anyone has experienced this, the answer you might think is obvious. Well, you do it to keep it quiet, okay? The crying is extremely annoying. You feed it, and then it settles down again. That would be an approximate explanation. A developmental one would be something like, well, maybe it's just a natural instinct, okay? Indeed, the sound of baby's tears can cause milk to start flowing, from a mother. So this is just a kind of natural instinct, or maybe she's learned how to do this through being taught or whatever. That would be a developmental explanation. A phylogenetic why would be, well, as a mammal, mothers produce milk to feed their babies, and so this is just typical mammalian feeding behavior. And then the final functional why is, by feeding the baby, you're providing it with calories and nutrition that are going to help it survive, and that is going to improve your evolutionary fitness. So if that makes sense, you understand evolutionary psychology. What I'd like to do now is just give you 3 quick case studies to show you how this kind of thinking can enhance and deepen otherwise sort of limited explanations of human behavior. So this idea contrasts with the standard view in psychology, certainly what used to be the standard view probably from the early to the late 20th century, which is somewhat crudely called the standard social science model, or even more crudely, the blank slate model. So the blank slate goes back to John Locke, I think it was, one of the philosophers a few hundred years ago, the tabula rasa, the Latin for blank slate, which is really the idea that when we are born, our brains don't have any knowledge on them. They're like a blank slate, and experience then writes knowledge and behavior onto the slate. And so if you're raised in different ways, that knowledge will be different and you'll end up behaving totally differently. And so this kind of blank slate thinking is very common. It's most people's default position when they learn something about behavior. So, for example, a blank slate view would suggest that sex differences between males and females of well, in humans, indeed any species, are down to learning. For example, if you note that boys are rougher than girls when they play, that's due to socialization. And you can even get some extreme examples of this. I picked one of the most extreme ones I could think of, which you do here, which is that men are taught to engage in the worst kind of behaviors like rape. And so to get rid of them, you just need to teach them differently. Then at the bottom, I just got a quotation here from one of the books that I recommend at the end, where the author, Steven Pinker, one of the kind of popularizers of this field, he collects sort of claims that he thinks are ridiculous, made in newspapers to explain human behavior. So little boys quarrel and fight because they're encouraged to do so. Children enjoy sweets because parents use them as a reward for eating vegetables. Teenagers compete in looks and fashion from spelling bees and academic prizes. That men think the goal of sex is an orgasm because of the way they've been socialized. So he would say these things are ridiculous, and a much better explanation is that there are instinctive, innate preferences for each of these things handed to us via evolution. So let's have a look at 3 examples to show you how this alternative view can change traditional thinking. So I've tried to pick very sort of stark and dramatic behaviors. Not all evolutionary psychology is like this. Some of it is much more, like mainstream psychology, but I wanted to give these some impact. So our first behavior is infanticide. So infanticide is the deliberate killing of an infant. It actually used to have, and may still have, I think, its own category in law. So it's not the same as a homicide if it occurs within the first 12 months of a child's life. And the model for this comes from animals. So here are some, on the left, you can see some stills from a video showing an infanticide in lions. So here we have a male lion with a mane and a juvenile. And the male is a new male who's entered the pride. He's taken over pride from an existing male, and there are some young already there. And you can see he swipes at the cub with his paw, he pins it to the ground, and then he bites it and kills it. And this is indeed what male lions will quite regularly do when they take over a pride. They'll actually kill the existing young. And the reason for that is it brings the females back into reproductive cycling. When the females are suckling the young, they can't get pregnant. So the male will kill the young, so the females will begin cycling, and then he can start siring his own offspring. And the females aren't wasting the time, from his point of view, looking after someone else's offspring. So the same behavior does happen in humans. When I say the same, I mean parents do sometimes kill their children. It's extremely rare, of course, and very tragic, but it does happen. And this graph here shows you, these are some data from Canada, looking at when these infanticides happen. And you can see it's much more common in the first year of life in the top graph. And after 1 year old, the rate drops to very low, to almost nothing. Now, you might immediately think, well, maybe the explanation for this is that young babies are just smaller and much more vulnerable than older ones. But you can probably rule that out by looking at the homicide risk, so being killed by someone other than a relative, on the lower graph. And here you can see the rate remains low throughout childhood. There's not a spike in the first year of life, suggesting it's not just being vulnerable to a bit of violence. And it only starts to peak when you hit teenage years and children start doing risky things. So these data were brought to the attention of a couple of the very early evolutionary psychologists called Daly and Wilson. And they were told this fact by a colleague who was a criminologist, that if a child is killed, the most likely suspect is the parents. And they thought, well, this is really weird because, from an evolutionary point of view, the last thing you'd expect is parents to be killing children, albeit in rare cases. But why on earth would that be the case? So they went and gathered the data in Canada and in America to check this out for themselves. And they confirmed that it was absolutely true. Parents are indeed more likely than anyone else to kill, especially young children. But then they did something that no one had thought to do, which is to have a look at differences between biological parents and step parents. So these data were all just aggregated together. So here is what happens when you separate out these homicides of children by biological parents on the left and step parents on the right. And you can see the same pattern, this kind of spike in the first year or two of life, but it's much, much more common when it's a step parent who is the perpetrator here, rather than the biological parents. The absolute number is smaller because step parents are so rare, but the relative rate is much higher. And they were the first to realize this. Now, this suddenly resolves that apparent conundrum, okay, because indeed it doesn't make evolutionary sense for parents to kill children except in the most extreme of circumstances. But with a step parent, the difference is they don't have that genetic bond, okay? They don't have a genetic interest in the children. And the suggestion here is not that humans are like lions, and if a step parent comes into the family, they'll systematically try and kill the children. That definitely doesn't seem to be the case. The vast majority of step parents are perfectly good, loving people, I should also emphasize. But these cases where, an argument spills over into violence, or just that kind of natural restraint that a biological parent has, seems to be absent or less present with step parents, leading to this higher rate. So again, it's only a tiny, tiny fraction of step parents who will ever commit violence, let alone murder, against children. But compared to biological parents, it's much higher. So this inspired these two researchers to write a book about this, and I recommend it at the end, and it's called The Truth About Cinderella. And of course, if you remember your childhood stories, Cinderella had that wicked stepmother. And in fact, if you look at many of these children's fairy stories, there is a common element, which is the wicked step-parent. And it's not just in European folk stories like the Grimm fairy tales and Hans Andersen and so on. You get the same if you look in traditional African stories and in Chinese and Japanese stories. It's a really common motif. And so Daly and Wilson speculate that there's some kind of folk awareness of this sort of risk of neglect or abuse with step-parents. So that's the first case study. The second one I've chosen is sex differences. And again, we start with animals. So the graph here shows how males and females of a species, in this case it's actually fruit flies, but it applies to any species, improve their reproductive success depending on how many mates they have. So if you look at the blue line, you can see that as you give a male animal more mates, it can increase the number of offspring it fathers, okay? Whereas for females, you can give them more and more mates, but that doesn't increase the number of children they can produce. So if you're a fruit fly, you can only lay 50 eggs at a time, okay? Doesn't matter if there are 10 males buzzing around you, you can only lay 50 eggs, you can only mother 50 children, or offspring, I should say. So this fact led Bateman to propose that males will be competitive because if they win these competitions, if they can attract more mates, they can really increase their reproductive success. There's big rewards for winning. And on the other hand, females can be choosy. So females don't need to compete. There's no advantage for it. And instead, they can just pick out the best males that they want to mate with. And this principle helps us to understand Darwin's idea of sexual selection. So Darwin noted that in many species, particularly mammals, males will compete with each other, like these red deer stags, butting antlers during the rut. Or if they don't compete directly, they compete indirectly through trying to appear the boldest or the brightest or the most active and so on, like in many birds. So we see here these water birds, and the male very brightly colored compared to the female. And this all relates back to Bateman's principle. Okay, so can we use that to explain human behavior? Well, it does indeed look like men and women differ in a number of ways, particularly when it comes to sexual behavior. So here is just a graph. I apologize, I know it's small and hard to see, but all we need to look at is the top two lines here. So this is a massive cross-cultural survey with tens of thousands of people. And it's just, this is one of the questions they were asked about their sex drive. So how strong is the sex drive? And the top line here is the males, and the bottom line here is the females. And these countries range from Russia to Brazil to Spain to Israel to Venezuela to Trinidad and Tobago, Congo, and so on. So loads and loads of different countries. And you can see in all countries, there is a difference between the men and women. The men report a higher sex drive than do the women. So this is an interesting way to look for human universals, things that seem to be common across cultures. And this is exactly what you'd predict from Bateman's principle, okay? Men have more to gain by being more sexually interested, more interested in sexual opportunities, even if you're not in a committed relationship. The other thing to note about this is that there is a lot of variation in this sex drive. So this line, both of these lines, they wiggle up and down, okay? So if you compare, what are these countries? I can't really see, but Saudi Arabia versus Australia or something, there is quite a difference between the two there. So that would seem to suggest that, there isn't just uniformity in this behavior, and that maybe culture does seem to be important. So the standard social science view would be you can explain these differences by looking for differences in the culture. However, you might expect that you're going to get bigger differences between men and women in countries where men and women are treated very differently, in gender unequal countries, and in countries where men and women are treated equally, so more gender equal countries, you might expect to see smaller differences. But I just want to show you this data, which came out quite recently, suggesting that this is not always the case. In fact, it's rarely the case. So this is a graph looking at sex differences in interest in subjects. So the subjects that men and women choose at university. So it's looking at the percentage of female STEM graduates, so science, technology, engineering, and maths graduates, in different countries across the world. And you can see it ranges from about 15% to about 40%. And on the other axis, we've got a measure of the gender gap. So the higher the number here, the more equal the sexes are. And this isn't in terms of political representation and laws relating to the two sexes and attitudes, things like that. So if you look up here, we can see countries like Finland and Norway and Sweden, well known for being very gender equal countries. Down the other end, we have Albania and Turkey and Algeria, which are not known for their gender equality. And there's a strong pattern between the two, a strong link in exactly the opposite way you would expect according to the gender equality hypothesis. Okay, in these gender equal countries, we get very few female STEM graduates, and in these gender unequal countries, we get quite a lot of them, almost getting up to 50%. So this is very inconvenient if you subscribe to this gender equality hypothesis, and instead it's much more reminiscent of there being an actual genuine sex difference in interest in STEM versus non-STEM subjects, and that these in gender equal countries, people are free to basically pursue their interests. Okay, whereas in these countries at the other end of the scale tend to be much poorer countries, and if you want to get ahead in life, it makes more sense to study STEM subjects because they're actually going to give you something more useful in life. And so women will pursue those. So again, this is an example of where I think this makes evolutionary sense, and it turns the kind of standard thinking on its head, and these data support that idea. And the final example we'll look at briefly is a reasoning task. So you can play along with this. What you've got here is a series of cards in front of you, and the cards have a number on one side and a color on the other side. And you can see 4 cards lying on the table, a 5 and 8, a blue card, and a green card. And you're told there is a rule, which is that if a card has an even number on one face, then its opposite face is blue. Now, your job is to tell me which card you have to turn over to test that rule. So I'll give you a moment to think about it. You could, of course, turn over all the cards and then you would find out. But the question is, which cards do you have to turn over? So the minimum number of cards. So I won't give you too long. Just go with your first instinct and see if it's obvious what the answer is. When I did this for the first time, it wasn't obvious for me. I got it wrong. So don't feel bad if you do as well. So probably a lot of you said you need to turn over the 8 card, and you would be correct. You do need to turn over the 8. You have to check that the reverse of that card is blue to check the rule. But the other card you need to turn over is not the blue card, it's the green card. The reason for that is if you turn over the green card and there is an even number, you falsified the rule. You've proven that it's not true. So the correct answer is 8 and green. But most people get it wrong. I got it wrong when I did it. Most people think it's either the 8 card alone or they go for the 8 and the blue card. Those are the most common answers. It's actually irrelevant what number the blue card has on its back. It could be even or odd. It wouldn't affect the rule. So this is a hard problem, and it was introduced in the 1960s. And like I say, most people get it wrong the first time they see it. So let me give you a different version of that problem. And again, just in a few seconds, see whether it's easier or more difficult. So you are a bartender, and your job is to make sure that if a person is drinking beer, They are 18 years of age or older. And then in front of you, there are 4 people. There's someone drinking beer, someone drinking Coke, someone who's 22 years old, and someone who's 16 years old. Who do you have to check what they're drinking, what age they are, to see if the rule is being followed? Well, here you can probably just see the answer instantly. You need to check the person drinking beer, check they're over 18, and you need to check the 16-year-old, check what they're drinking. This is logically exactly the same as the previous problem in terms of its sort of mathematical structure, but people find this much easier, and almost everybody gets it right. Okay, so what's this got to do with evolution? Well, these kind of tasks have been subject to a whole load of different examples, including familiar versus unfamiliar examples, and there's a very consistent result, which the people are really good at doing it when it's a rule about sort of adhering to a social convention or adhering to the rules, social rules. But when it's something abstract or something not to do with that, even if it's familiar, people find it much harder. And the idea is there might be a part of our mind which is just tuned in to checking whether people are breaking the rules, these social rules, that just isn't tuned in to these abstract versions or these kind of non-rule breaking versions. So hopefully that gives you an idea of the kind of way you can use evolutionary psychology. You might be interested in, it's often subjected to various critiques, evolutionary psychology. Now, one of the very common ones is that it just seems like a bunch of just so stories. So those Rudyard Kipling stories. Whenever I tell my students about the just so stories, they sort of look at me blankly. I don't think they're read anymore, but I trust this audience is better read. So these are these fantastical stories explaining how the elephant got its trunk and how the leopard got its spots. So these, sort of fairy tale histories. And the charge against evolutionary psychology is that you can just make up any old explanation to explain something, and it's impossible to tell whether it's true or not. Now, the first half of that charge has some merit to it. It is indeed possible to make up any explanation that you want to explain something. But the second half is not true. There are ways of testing whether something seems to be evolved or not. So can't go into huge detail, but here are the 4 pillars of how you can do this. The first thing you can look for is cross-cultural universality. Is this the behavior that all humans seem to exhibit? If so, that's a strong clue that it might be inherited through our ancestry. The second thing you can look for is developmental consistency. So if the behavior emerges early in childhood, before really learning has had a chance to make much of a difference, then that's, again, good evidence that it's something that's evolved. And if it develops in the same way in different people, despite their very different experiences, then that's a very strong suggestion. The third thing you can do is look at other species. So look at the phylogenetics. Do we see these kind of behaviors in other species? Particularly, you might look at closely related species like other primates, but also many mammals. And I mean, if you look at human sexual behavior, for example, my particular area, then the birds just look exactly like humans, even though they're very, very distantly related. But that's good evidence that there's a common evolutionary pressure acting on these animals. And then the fourth and most important piece of evidence comes from functional design. So does this behavior look like it's designed to improve fitness? So take a physical trait like the eye, for example. We can see the design of the eye is very precisely made to focus light onto the retina, to transduce electromagnetic information into chemical and electrical information in the nerves and so on. Real evidence of design there, suggesting evolution. We can do exactly the same thing with behavior. So very brief introduction there. I've just put on this slide 5 books, probably the 5 best books that sprung to my mind if you want to learn more about this. So this is the one I quoted from earlier, Steven Pinker's Blank Slate. That's a really good just general overview of the contrast between the blank slate and the evolutionary views. Then the evolution of desire is about human sexual behavior. The selfish gene is not about human behavior, but it's just, it's 50 years old now, but it's still a kind of almost 50 years old. It's still a state of the art of how to understand evolutionary biology. Then they've got the Daly and Wilson book about Cinderella I mentioned. And the last one is, it's about criminology. And a lot of it is about brain activity in criminology. But the reason I chose it is that the author also takes an explicitly evolutionary approach. And it's a really nice example of how you can use these theories to understand this particular area of psychology in terms of criminality. So that is the end of the presentation, and hopefully I'll switch back to having my face on your screen.
Hello.
Hello.
Let's make it big. How's that? Yeah.
Perfect.
So you said a lot of stuff there, which was very interesting. Do you know, when I'm engaged in discussion with people and they start the why questions, much like you, I tell them that why is not just a question. It's a question plus an assumption. The assumption that there is a reason, a purpose, or a meaning wrapped up in that supposed question. All the other questions can be answered. What, where, how. They can all be given a closure, an answer that finishes the question. Why can't? Why is a different sort of beast? And that's why children can annoy you by keep saying why.
Yes. Well, actually, that's the reason that the evolutionary approach I find very satisfying. Because you're right. So take any psychological behavior and you can say, oh, it's because of the hormones or the nerves in your brain. You can say, yes, but why? Oh, well, it's to do with the genes you inherited and how you're brought up. Yeah, but why? If you keep tracing that chain of whys all the way back, you get to the kind of bedrock, which is, well, your ancestors did it, and the ones that did it survived and reproduced, and that's why you did it. Okay? And that is actually, in itself, that is the answer. You can't get any more whys than that, because it's just true. If evolution works like that, then it will automatically, like an algorithm, come to that solution. So that's why I find it's such a satisfying way of understanding behavior.
That's the foundational level when you get there. So something else that drew to my attention is reminded me of some experiments that I've heard about where young rhesus monkeys, we're on sex now, were given an option and of what to play with, and the young female preferentially cuddled the dollies, and males preferred to play with the toy cars. So that sort of goes along with what you were saying, does it, about there being benefits to sexual differences?
So the issue of boys and girls playing with toys is one that crops up periodically. And like I said, most people's assumption, I think, would be that the reason boys and girls prefer different things is because the parents treat them differently. So they give them a particular toy to play with, or they're socialized by, adverts on TV or their playmates at nursery to pick particular toys. Okay. I think that's most people's default. And those nice experiments with the monkeys, it's been done on a few species now, quite consistently show that you do see sex differences. It's actually, when you look at the what they play with, it's not quite as simple as the females preferring the cuddly toys, the kind of dollies and things. So monkeys are curious; they'll play with anything. You can put anything in there; they will go over and play with it. Okay, so the females are actually they'll just play with anything. So they had, in one experiment, they had like trucks and things like that, and then some animals and dolls, stuffed toys. And they play quite equally with them. They don't have a strong preference, but it's the males who behave quite differently. The males will play much less with the dolls and the things that look like babies, and they'll play with the other things instead. And so how I would interpret that is that they're all interesting objects that they want to play with, but the males have had bad experiences when they try and play with small things that look like little monkeys. Okay, so in most monkey groups, it's in many of them, they're female bonded. So females are in charge, and they kind of dictate who can do what. And when a new baby is born, it's just a huge source of interest. Everyone wants to play with the baby, and the female will allow others to come and hold her baby as a kind of reward. Okay, it's like a status symbol. Now, if a male comes along, just gets too near that baby by mistake, the female will come and whack it. Okay, so they learn to keep their distance when there's a young baby in the troop. Okay, they just leave it alone because they'll get into trouble. And so these males probably have just this innate, possibly learned aversion to going too near these new baby objects because it could spell trouble for them, whereas the females just find them just as interesting and want to go and play with them. But it definitely suggests that there is some kind of evolved, inherited predisposition towards different types of objects. Yeah.
Yeah, this is the old nature versus nurture conundrum.
Yeah.
So, sex selection. It's reversed in humans, isn't it? I mean, male birds are the pretty ones.
Yep.
Females are rather dull.
Yep.
But in humans, it's the females that adorn themselves rather than the males, commonly.
Mm-hmm. Yep.
And yet it's still the females that do the choosing?
Yes. So females are undoubtedly choosier than men. You probably experienced this sometime in your own life. I think most heterosexual men have. But you are right. It's a bit odd in that women will spend a lot more on clothes and makeup and so on, which doesn't seem to fit the usual mammalian pattern anyway, or the usual bird pattern, really. So one of the big differences is that humans are quite unique, not totally unique, but among primates, we're one of only 2 or 3 species which are monogamous or fairly monogamous.
Yeah.
Most primates are either promiscuous or the male will guard a harem of females. Yeah. So in a monogamous species, the pressure is actually more evenly spread between males and females to be competitive. Okay, because if you can only choose one partner, if you haven't got the option to have loads and loads of partners like a male gorilla would have, then there's less pressure on you to be so competitive. Nevertheless, I would still argue that men are more competitive than women. So in many different ways, not in terms of physical adornment, although there have been times in history when men do plenty of adornment, but in lots of other ways, men compete quite strongly with each other for women's attention or for social status or for that kind of thing. So I think we do fit the pattern of a monogamous species.
So when we do have polygamy, it's more commonly polygamy rather than polyandry.
Yes.
Does that fit in?
Yeah, so polyandry is extremely rare. So this is when a female has several male partners. We see it in a few insects. We see it in a few birds. A few scattered groups show polyandry. Most species in nature are polygamous. So the male mates with multiple females. Now, humans, interestingly, show the same pattern within one species. So although I said we're kind of monogamous, actually, a majority of societies in the world allow polygamy. So allow a man to have more than one wife. It doesn't seem like that's the case. We live in the Western world. But in terms of number of societies, so many small-scale societies, that's actually allowed. Right. We also see a few, maybe 1 or 2 polyandrous societies still existing in the Himalayas. So in Nepal and Tibet, we still get some polyandry, where it's typically 2 or 3 brothers will marry the same wife. But again, extremely rare. They're actually the same kind of pattern as we see in nature. And the reason that polyandry is so rare goes back to Bateman's principle. Okay, a female doesn't really gain anything by having multiple partners, except you can gain, extra resources on your farm in Tibet if you live there. Whereas a man can gain just direct offspring by having lots of partners. I do know off the top of my head, the record for the most number of children produced is about 890 by a North African sultan in about the 10th century or something. So he had hundreds of wives, and he had over 890 recorded children. Whereas the highest number of children a woman has ever produced is, I think, 67, something like that, which is it's actually an even more amazing statistic. It was a Russian peasant woman in the 19th century, I think, and most of them survived as well, which is remarkable. But you can see the big difference between the two.
Yes, multiple births, presumably.
Yeah, lots of twins and triplets and quads as well. He was just very prone to them. Yeah.
So, what about creatures like the cheetah, where the sexes are very similar? You can't just.
Yeah.
What would you say?
So typically, when you look at mammals, you can kind of tell the mating system by looking at the physical size of the animals. So if you take the gorilla, for example, the gorilla males are substantially larger than the females. That's because he will mate with several females. So there's a big selection pressure for the male to grow big and strong. You can fight off rivals. An extreme example is the elephant seal. The male weighs about 3 times more than the female, and they have these huge fights on the beach where they bash their heads until one of them is just left in a bloody mess on the floor. And they will guard, if they're successful, they then guard an area of the beach where they can have a dozen females to mate with. Whereas when animals are very similar in size, it suggests they're more monogamous, or at least the males don't engage in competition. I must admit, I don't know offhand what the cheetah mating system is if they are monogamous. I'd be surprised because most mammals are not. But if you take gibbons, for example, a primate group, they're one of the other primates that are monogamous. And so gibbon males and females look very similar. You can't really tell the difference between them. The males don't really do much fighting. You might get occasional scraps, but there's not huge competition between them because there isn't the pressure for it when you're monogamous.
I understand that it's very difficult using the external sexual features to distinguish one cheetah from another.
Oh, right. Okay.
Anyway, what's going to happen in China now that they've upset their sex ratio? Are they going to have to go polyandry?
Yeah. It's very interesting. Actually, it has big social effects when there's an excess of one sex compared to another. Essentially, the rarer sex becomes a stronger bargaining partner in the market. They can have their pick of, in this case, the men. Okay, and there are loads of men who are just left without a partner, and they're sort of cause big problems. Yeah,
quite angry, many of them.
Yeah, definitely. Yeah.
So I tried. Viewers would like to hear that my attempts to get guests on this show. One of those I've tried to get is Frans de Waal.
Oh, Frans de Waal. Okay, yeah.
What do you think? Wouldn't he be good? He's turned me down, by the way, because he says he's doing too many podcasts at the moment. Maybe I'll try him later on, but I'm a great admirer of the way he's investigated the rudiments of morality. Does that cross your field of?
Yes, he's got some very famous videos, Frans de Waal. I saw him. I've seen him talk at a conference. If you go on YouTube and just Google his name, YouTube his name, you can find some really interesting videos where he demonstrates inequity aversion among monkeys.
Yes.
And so this is when monkeys are trained in their cages to donate tokens in return for food. Okay, and they readily do this. They give a little stone and they get a grape in return. And this is useful for shaping their behavior when you want to do some experiments, and they enjoy doing it. Yeah. But if you have 2 monkeys next to each other and one of them trades their stone for a bit of cucumber, which is, cucumber, it's okay, but anything else is better, they'll do that quite happily. But if their neighbor trades the same stone and gets given grapes or something that's much higher value, then the first monkey will now no longer go along with the bargain. It won't trade for cucumber anymore, even though it's perfectly happy a little while ago. So de Waal suggests that these animals are sensitive to they're not just sort of conditioned by stimulus and reward in the sort of traditional old way of understanding animal behavior. Instead, they're sensitive to what others get. And if someone else is getting more than you're getting, this upsets them. And in fact, the same thing's been shown in other species like dogs as well. Dogs seem to do exactly the same thing.
They have a sense of fairness. Now, is that learned or evolved?
Well, if you see it in other primates and if you see it in dogs, then that's very strong evidence, if you ask me, that it's evolved.
Yeah, likely. I have a question here. I don't know who it's from because they didn't enter their name. This says, in humans, unlike many other mammals, females dress in a showy way, and males dress in a manner that is comparatively dull. We've covered this, really, haven't you? What is the suggestion that money is an important resource in humans, and that so long as men make more than women, there will be pressures to women to compete for men, which is the inverse of the way things play out in many other species?
Yeah. No, it makes sense. Absolutely. So I agree that money is an important resource, and men seem to be much more bothered about money than women. So if you look at things that are important in a partner, men don't really consider how wealthy your partner is or how educated to be that important, whereas women do consider how educated and wealthy their potential partner is to be important. And if it's something the other sex considers important, then there's a pressure for you to compete to get it. So this suggests, and it seems to me true, that men do compete more for money, for status, for jobs, and so on, than women do. But yeah, the question is exactly right. There's also the reverse pressure for women to compete with men. And actually, a really nice example of this, a study that came out last year or 2 years ago, I think, looking at Instagram. So if you've ever browsed certain areas of Instagram, a popular topic genre is just women wearing skimpy clothes, okay, just posing in their bathing costumes and so on. And what this study did was look at how common these types of posts were, and again, in all different countries of the world. And what the study showed was that in countries where there's big inequalities, so big differences between the rich and the poor, you get a lot more of these sort of sexualized posts, suggesting that it's women competing for men, right? They're advertising themselves, how attractive they are to get these high quality men. Whereas in the relatively equal countries, you don't get so much of this type of content because there isn't this sort of pressure to compete to get the best partner for women.
Yeah, this is a Cinderella story again, isn't it? The poor girl, am I thinking the right one? Poor girl seeking a prince as a partner.
Yeah. That's right. Yeah. There's the stepsister seeking the prince, and then she's the one that gets him in the end by glamming up and becoming beautiful. Yeah.
So what somebody has said, I don't know who, that women give sex for love, and men give love for sex. Is that just a nonsense saying?
Well, it's a sort of crude cliche, but there's some truth to it. If I was taking a more sort of ethological version of it, so studying animal behavior, you'd say the females give sex for resources, the men give resources for sex. And there's also, it can be food, it can be a territory, it could be a nest in different species. But love is a form of resource, if you think about it in a rather unromantic and kind of utilitarian way. It's a kind of promise of future protection and so on.
Yes.
There's truth to it, crude, the saying is.
Rather passionate view of relationships. So here's another question. Ravi Dunn. I think he's not in this country. I can't remember where he hails from. But he says, I read recently that 80% of women contribute to the gene pool of 40%, whereas it's about 40% for men.
Yeah.
Given that monogamy is the norm, what's happening here from an evolutionary psychology perspective?
Yeah, again, the question is exactly right. So this is the way I put it to my students. If I asked you to draw a family tree, you've got a mother and a father. They have a mother and a father. They in turn have a mother and a father. If you were to count up all your male ancestors and your female ancestors, how many of each would you have? And people assume you'd have an equal number, right? Because you've got to have a mother and father all the way up. But the answer is no. You have about twice as many female ancestors as male ancestors. And we know this from genetic studies. So if you track the Y chromosome, which is inherited only down the male line, and if you track the mitochondrial DNA, which is only inherited down the female line, you can see there's twice as much variation in the mitochondria than the Y chromosome, so twice as many ancestors on your female side. So this is a puzzle, because in a monogamous species, you should have equal numbers of male, female contributing to the next generation. So this is very strong genetic evidence that we are not entirely monogamous. We're actually a slightly polygynous species.
Right.
It actually fits with our physical appearance as well. So I mentioned you can look how big animals are to get a good clue as to the mating system. Well, men are about 10% larger than women, something like that, suggesting we had a history of polygyny. So partly this could be, men having multiple wives. And if, given there are equal numbers of men and women born in a generation, if a man has one extra wife, then that means there's one man who doesn't get a wife, and his genes will die when he dies, and he'll be excluded from that genetic inheritance. The other way it can happen is through serial monogamy. So serial monogamy is when you have a partnership, maybe you're perfectly faithful throughout it, and then it breaks down either in death or in divorce, and then you marry someone else. And the typical pattern is that men will marry younger second and third wives than their previous wives. And in exactly the same way, that means a man is taking more than his fair share of reproductive years from the other sex. And that will, again, by definition, exclude other men from their fair share. So that will also shift the system towards polygyny and cause you to have more female than male ancestors.
I'm not blushing, am I?
No, I don't think so.
Good. There's obviously been a fair bit of hanky-panky going on in the human race.
Yeah, I mean, that's what evolution is all about, ultimately. You can survive and get food and avoid predators, but if you don't reproduce, then that's it for your genes.
Yes. So, Ravi Dunn says he's in Bristol. So I was mistaken, thinking that he's from some far-flung part of the universe.
That's quite exotic, Bristol.
Well, Ed, coming up to the end of our time, I like to encompass on these shows. Otherwise, I fear that people may be thinking of going off to watch a TV show that starts at 9 o'clock. I was doing that myself for the early part of this week when they were showing the drama documentary of the Salisbury Novichok poisoning.
Oh, I haven't seen it. Is it good?
I recommend it. Yes, it's really good. But it starts at 9 o'clock, and so do a lot of other programs. So this is why I bring this event to an end.
Okay.
Thank you very much. You've been brilliant. We'd love to have you come another day and discuss some of those other subjects that you listed to me in your email. I'd particularly like to hear your thoughts on the evolution of morality. So maybe you'll accept an invitation again in the future.
Yeah, I'll be very happy to. Yeah, happy to come back on.
Great. Excellent. Meanwhile, to the viewers, next week we have Dr. Mark Darcy, who is an expert in aging. He's a lecturer at 2 universities. He's going to tell us why we age, what can be done about it, and maybe what happens at death. So that should be well worth tuning in for. And then it's Blair Whitby, who, as you know, has been postponed. And then following Dr. Blair Whitby, that's on the 1st of July, we have Dr. Sam Gregson, who we haven't fixed the date for him, but he's coming to tell us about hunting the Higgs. He was at CERN when the Higgs was discovered a few years ago. So do tune in to those people. Thank you very much, and good night.
Thank you, John. Good night.
Thank you. Bye-bye.